Welcome to a new video presented to you by APC Mastery Path. APC Mastery Path provides videos related to how to implement the latest artificial intelligence and machine learning within our beloved construction industry. This video belongs to a series of videos that will tackle how to use open source LLMs to build a tool to convert PDFs to a functioning and useful podcast. The system that will be presented in this series relies on four main pillars. Pillar 1, PDFs loading and pre-processing. Pillar 2, writing transcript. Pillar 3, refining the created transcript. Pillar 4, text-to-speech workflow. In the first video, we discussed a part of the first pillar. We showcased how to set up the coding environment, load the PDFs, extract raw text and save that raw text in a file. The output file of this video was a raw text which is uncleansed and contains a lot of white spaces alongside irrelevant text information, page numbers, and the likes. In the second video, we discussed the outstanding part of the first pillar. We used Llama 3.18 billion parameter large language model to make sense of the extracted raw text and reword it to make more sense in preparation for the next steps. The output from this video was a much more cleansed text file which was done by the uploaded LLM of choice. It made its best to remove the white spaces and unnecessary text. This file is now more in shape and ready for the next step. In this video, we are going to discuss the second pillar. We will make use of the cleansed text from the previous step to be the backbone of writing the first iteration of the podcast script. Having understood how we are going to tackle this project, let's dive in. This project was crafted by the Meta team and they have provided the full code on one of their GitHub repositories that I will be putting the link for in the video description below. I have also created my own refined code and uploaded it to a separate GitHub repository which I am going to be providing the link for in the video description below as well. This will make the process of following through and implementing the project much easier for the listeners. Step 1. Creating an effective system prompt. System_prompt is used for setting the model context or profile for working on a task. Here we prompt it to be a great podcast transcript writer to assist with our task. Step 2. Import libraries and configure warnings for model processing. This is just a basic step to import essential libraries needed for deep learning model processing, device management, text generation, and file handling. Additionally, it sets up a warning filter to suppress unnecessary warnings, improving the clarity of the output. These imports provide the necessary tools for handling large language models, efficient device usage, progress tracking, and saving output data. Step 3. Read file with flexible encoding handling. In this step, we defined a function, read_file_to_string, which reads the content of a text file into a string. The function is designed to handle multiple file encodings, attempting several common encodings if the standard UTF rate fails. It also includes error handling for cases such as file not found or read errors. This flexibility makes it robust for reading files with various encoding formats. Step 4. Open file dialog to select the clean and extracted text file. This step is crafted to make the process more appealing for the end user by creating a file selection dialog using TTS library to allow the user to choose a .text file from their system. Once the user selects a file, the file path is stored in a variable called input_prompt. This file path can then be used for further processing. The code is simple and provides a straightforward way for users to specify input files interactively. Step 5. Initialize text generation pipeline and generate text. This step tackles the process of creating a text generation pipeline using the Hugging Face Transformers library. It loads a pre-trained language model configured with specific parameters, then feeds it a structured prompt, composed of a system instruction and user input. The pipeline generates text based on the prompt, with options for customizing the output length and randomness. This setup is essential for leveraging large language models to generate contextually relevant text. Step 6. Define output path and save generated text. This step builds on what we created above by defining the file path for saving a generated .pkl file based on the directory of the initially selected .text file. It retrieves the generated text content from the model's output and assigns it to a variable, save_string_pkl, for saving. The file path setup and content extraction ensure that the processed output is saved in an organized way, alongside the original input file in the same directory. Step 7. Save generated text as a .pkl file. Having generated the PKL file and identified where the end user wants it to be saved in the previous step, this step saves the generated text content to a .pkl file at the specified path, using Python's pickle module. After saving the file, the code assigns the file path to a variable, generated_pkl_path, for easy reference, ensuring that the saved file can be accessed later. This step completes the data processing workflow by storing the output in a structured and accessible format. The main output of this video is the first iteration of the podcast where there are two speakers having a conversation. The first iteration is quite promising as it contains some emotions in the text, which is going to be reflected further when this transcript is refined and finally converted to voice. Also, the flow of the conversation is quite smooth with little to no drops in the tempo of the speakers. This transcript is going to have further refinement, which we are going to explore in the next video. All the files that we are explaining in this series of video are available on my GitHub repository, provided in the video description below.
Thanks a lot for watching. Hope you found this video useful and insightful. I've prepared a couple of other videos about fine-tuning large language models and deploying them to OpenWeb UI. I'm going to be putting the links in the description below. You can also pay my website a visit at www.apcmasterypath.co.uk, where I provide multiple packages for the RSS APC candidates to support them throughout their RSCS journey. Also, I provide lots of insights about the RSS APC process, the different areas of competence, and how you can deploy AI within the construction industry. Do not forget to hit the like button and subscribe so that you get notified about our latest videos.